All right, this is the lesson from day 24, Monday, March the 2nd on balancing equations. So I'm going to work through the solutions for you here, and you will have those to be able to submit. Okay, so I'm going to do the first one using the box method. I won't do every one using both methods. I'll probably just switch back and forth between the box method and the shorter method. Okay, so we'll use the box method this time. So you draw a box and you put two N's in it. Draw a box here and put two H's in it. Draw a box here and put N and three H's. So you never put the subscripts in the box. You always break H3 out into three different H's. Okay, now what you do is you simply have to get the same number of N's on both sides and the same number of H's on both sides. And you do that by adding boxes to the side that has the least. So you choose which one are you going to balance first. So we'll balance N's first. So we have 2 on this side, 1 on this side. That means I have to add a second box so I get a second N. I can't just add the N, I have to add everything in the box. I have to do an exact duplicate of that box. So now I have 2 N's and 2 N's, so N's are in balance. Now I have 2 H's, and over here I have 1, 2, 3, 4, 5, 6 H's. So I need to get 6 H's over here. Okay, so now I have 6 H's on this side, 6 on this side. I have 2 N's on this side, 2 on this side. Everything's in balance. So the number of boxes will be the coefficient. That is the number that goes in front of each of the elemental molecules or the compound. So this is a 1, this is a 3, this is a 2. Okay, and that's how you do that. All right, this next problem, number 2, we'll use the more abbreviated method. So the way you do that is you write the elements underneath the arrow. Okay, a lot of students read this as, they think this is a CI. It's not, it's chlorine, it's Cl. So whenever you see that, it's almost never in chemistry are you going to see Ci, which would be carbon and iodine, but it's C with a lowercase l, so it's chlorine. Okay, and then we have O. Okay, and that's all the elements we have in this reaction. So now we count atoms. Subscript there is 1 since you don't see anything, so there's 1 potassium, 1 potassium. Chlorine, we have 1 over here. Over here we have 1. Oxygen, we have 2 over here, and we have 3 over here. So everything is in balance except for oxygen. So you see that there's no number of times we can multiply 2 to get 3 because we have 3 oxygens there. So what we're going to do then is we're going to, what's the lowest number, what's the smallest number that both of these go into? And that would be 6. So I multiply 3 by 2 to get 6. And I multiply this 2 by 3 to get 6. So now we have 6 oxygens on both sides. But we've thrown the K and the Cl out of balance. So now we have a 2K and a 2Cl. Because remember, this distributes. This 2 is for K, it's 2 for Cl, and it's 2 times 3, which is 6 for oxygen. So in order to get that back into balance, we have to put a 2 right there. So now everything is in balance. You have 6 oxygens, 2 potassiums, 2 potassiums, 2 chlorines, 2 chlorines, and that's it. So you can go ahead and erase these. You write them up here because you may have to change them more than once throughout the problem. So you can go ahead and just erase them and put a 2 and a 2 and a 3, and that's the answer, okay? What I'd like to see you do on a test then is count. So what I said was there's 6 oxygens, over here 6 oxygens, 2 potassiums, 2 potassiums, 2 chlorines, 2 chlorines. So these numbers match up. They're balanced. All right? Okay, let's keep going. And I'll do this one using the box method. So I have NaCl and fluorine. Remember, that's one of, we talked about this today. That's one of the diatomic molecules. There's 7 of them. That's table salt, and they're going to break apart. It's a single replacement reaction where the fluorine takes the place of the chlorine. They're both -1 charges. If you look at your periodic table, and then the chlorine forms a diatomic molecule of Cl2. Okay, that's not important to the balancing, but just talking about chemistry a little bit. Okay, so here we go. We got this box with an Na and a Cl. This box, remember you never use subscript, so it's F, F. It's just 2 F's. This is NaF, and this is ClCl. All right, so pick whatever you want to balance first. The Na is already in balance because there's one on each side, so you don't start with that. We'll pick fluorine. So I have 2 here and 1 here, so I need another Na. F. So now the fluorines are in balance, but I threw the NAs out of balance. That happens sometimes, so you'll go back and deal with that later, or you can deal with it right now. Let's put the NAs back in balance by putting another box here. Okay, so the NAs are back in balance, the fluorines are in balance, and it just so happens that by doing that, we ended up with the chlorines being in balance, okay? So you have 2 boxes here, 1 box here, 2 boxes here, and 1 box there. And that's your answer for that. All right? Okay, this is one you've seen before in class. Let's just balance it the simple way. So you got H and O. So you have 2 H's on this side, 2 H's on this side. You've got 2 O's on this side and 1 O on this side, so you have to balance it. So you put a 2 here. So 2 times O gives you 2 O's, so this becomes a 2. But it also makes 2 times 2 or 4 H's. So now you have 4 H's there. So the oxygens are in balance, but you threw the hydrogens out of balance. So now what do you have to multiply this by to get 4? You have to multiply that by 2. So you put a 2 up here. And so you have 2H2, there's 4 hydrogens, 2 oxygens, there's 4 hydrogens, and 2 oxygens. Remember, this distributes through to both of these. And so that's your answer. It's 2, 1, 2. You can just scratch those out. Okay? And that's that. All right. Okay, let's do this next one. Let's do it using the box method. Now, remember what I said. Let's see. Well, don't remember what I said. I was going to say if you have a hydroxide and OH on one side and another OH on the other side, you can just treat those like individual elements, but you don't have an OH on this side. So you're going to have to just, treat it as it is. So I'm going to treat this. What this means is it's 2 O's and it's 2 H's, just like a coefficient distributes. If you have a subscript outside of parentheses like that, it means you have 2 oxygens and 2 hydrogens. Okay, so what I'm going to do is I'm going to write PB O O H H. Or I could have written OH OH. It doesn't really matter how you wrote that. You have 2 OH's there, as long as you count the individual atoms correctly. Over here we have hydrochloric acid. That's what we dropped our zinc into. H and Cl. Here we have water, and that's HHO. And here we have lead chloride. That would be lead 2 chloride. But that doesn't matter right now. We're just counting atoms. Okay? All right, so there we go. So what are we going to balance? Well, the lead is already in balance. Don't need to balance that. You can start with the chlorines. You got 2 here and 1 here. So I'm going to add another HCl here. Okay, and let's see what I got here then. I got 2 Cl's and 2 Cl's. I've got 1 lead and 1 lead. How about hydrogens? Well, I have 1, 2, 3, 4 on the left side of the arrow and 1, 2 on the right side. So I'm going to add another HOO here. I said HOO, it's HHO right there. Okay, so hydrogens are in balance. So 1, 2, 3, 4, 1, 2, 3, 4. Lead's in balance, chlorine's in balance. And by doing that, I put the oxygens in balance. 1, 2, and 1, 2. So that's your final answer. 1, 2, 2, 1. Okay? There's no shame in using the box method, even though it's considered a beginner's method. It just can take a lot of space sometimes and can be very slow. But use it as long as you need to use it, as long as you get the answers right. Okay? All right, we're going to move on to one more here. Well, to a few more, but this one's the last one on this page. Okay, so let's go ahead and let's do this the short way. Al, Br, K, potassium. And you notice you got SO4s on both sides. The SO4s are not going to break up, so I'm going to treat them like an individual element and just call it SO4. So we treat those like an element. Okay, it's sulfate. So here we go, Al and Al2, so there's 2 here, 1 here, Bromine, there's 3 here. Bromine, there's 1 there. Potassium, you've got 2 of them there, and 1 of them there. And then the sulfate, you've got 1 of them. What you can do is you can put this in parentheses like that, SO4. So you have 1 of them on this side, and over here you have SO4, you have 3 of them there. So you put a 3 there. Okay, what's the easiest to balance? Looks like either potassium or aluminum. So we're going to add, put a 2 up here for aluminum, change that to a 2. That also means we now have 2 times 3 or 6 BRs. So I'm going to scratch that and make that a 6. Okay, so if we're going to put BR back in balance, we have to put a 6 up there. So now I have 6 BRs. Excuse me, 6 BRs, so I'm going to put a 6 there. So bromine is in balance, aluminum is in balance. Okay, potassium, though, is out of balance. You have 6 potassium, 6 in front of the K is 6K, and there you have 2 potassiums. So in order to make that equal to 6, I have to multiply that by 3. So I put a 3 there. So 3 times 2 is 6, and 6 times 1 is 6. So potassium is in balance, and by doing that, it turns out we put the SO4 in balance. You have 3 SO4s, 3 of everything that's in that parentheses, and over here you have 3 of everything that's in that parentheses. 2 different ways to multiply by 3 there, okay? All right, so everything's in balance. So we can go ahead, and this is going to be a 2, and a 3, and a 6, and a 1, right? Yeah, just a 1. Okay, and this scratches out, just scratch those out. You don't need those anymore. And that's it. Okay, so we'll move on to number 7. Okay, so here we go. We have the first right here, number 7, is the first of 3 combustion reactions. And let's go ahead and do that one here. That's a 4. I'm sure that looks like a 4. Okay, so you have what's called methane or natural gas combusting with oxygen to form the products that it always forms, a hydrocarbon, and that's a carbon dioxide and water. All right, let's do this one using the box method, okay? So we do this. All right, so you don't want to start with oxygens because there's 2 here, there's 1 there, there's 2 there. It's a mess. It appears in 2 different locations on the same side of the arrow, and I told you to avoid those. So let's go ahead. Carbon is already in balance, 1 and 1, so hydrogen's our only option. We have 2 hydrogens here and 4 there, so we're just going to draw another box here. Okay, now we have 4 hydrogens. Carbon's already in balance, and oxygen we have 1, 2, 3, 4, 5, and here we have 1, 2. So we're going to have to add a box because we have 5 on the right and only 2 on the left. So we add those, and now we have still 1, 2, 3, 4, 5, and 4 here. So we still have fewer on this side, so we have to add another box there. So that's OO. So now we have 6 on this side. And 5, oh, whoops, I counted that wrong. Sorry, that was my mistake. That was terrible. That's a terrible mistake. Okay, so let me erase that. Don't know why I wrote 2 O's there, but I did. Okay, so there's only 1 O in this box. So anyway, let's go back to where we had hydrogen in balance, 1, 2, 3, 4, 1, 2, 3, 4. And we had carbons already in balance. And over here we had 2 O's, and over here we had 1 O. So let me try this again. I'm just going to take that back. Sometimes you goof, you know. That's why you do things in pencil. All right. So we have 2 O's there. And let's see, we had to have 4 O's. So now we have 2 O's on this side. And excuse me, 1, 2, 3, 4 O's on this side and 2 O's on this side. So yes, we are going to add another pair of O's here. So you have 1, 2, 3, 4, and you have 1, 2, 3, 4. So the O's are in balance, the H's 4 and 4 are in balance, and the carbons are in balance. So it's 1, 2, 1, 2. Okay, and that's how you balance that combustion reaction with the hydrocarbon methane. Now we have another hydrocarbon called pentane. And that's C3H8, but notice everything else is the same in the equation. So let's do this one. This one is the one, if you remember from class. Let's see. Oh, it is not the one from class. I'm going to go ahead and do the next two using the shortcut, because if you try to draw boxes, you're going to have a lot of boxes. So let's just go ahead and learn to do this eventually. Do it this way. Saves you some space. So we have 3 carbons, and you have 1 carbon on this side. You have 8 hydrogen. You have 2 hydrogen on this side, 2 oxygen on this side, and you always start off with 3 oxygen on this side. Okay, all right. So what's the easiest thing to balance there? Looks like the carbon. So we have 1 here, 3 here. So we want to make this, multiply that by 3. So you put a 3 up there. So now we have 3 carbons. We now have 6 oxygens. So we have to change our oxygens to 6. Okay. I take that back. We have to change it to 7 because we said 3 times 2 is 6 plus the 1 more over there. So now you have 7 oxygens. So these combustion reactions are always a little bit weird because you start off with an odd number on one side and an even number on the other for oxygen. So it always makes them a little quirky. Okay, let's go to hydrogen next. You always save the oxygen for last because there's 2 different oxygen locations where oxygen exists. So 8 and 2, you have to multiply this by 4 to make that 8. So you put the 4 right there. 4 times 2 gives you that 8 right there. So hydrogens are in balance. Carbons are in balance. Now we also have to change our oxygen here. So it's 4 times 1 is 4. And over here we have 3 times 2 is 6. So we have 6 plus 4 gives us, now we have 10 over here. So now it's nice that we have even numbers on both sides, 2 and a 10. So to get that 2 to equal to 10, we have to multiply it by 5. So that gives us 10. So we have to put the 5 right there. All right, so we have 5 times 2 is 10. And over here we have 3 times 2 is 6. 4 times 1 is 4. 6 plus 4 is 10. So that's balanced. Everything's in balance. So those are our coefficients. 1, 5, 3, and 4. Okay, and you can scratch those out. All right, and that's it. Okay, now we're going to move on to octane. This is what's in gasoline. And this is that crazy one that if you remember from class, there were 25. That coefficient's going to end up 25. Now, we're not supposed to know that ahead of time, but we do. So I'm going to stay away from the box method because you'd have to literally have 25 boxes or some crazy thing like that, okay? All right, so here we go. We go CHO. Carbon, I got 8 on this side and 1 on this side. Hydrogens, I have 18, and I have 2 on this side. And oxygens, I have 2 on this side, and as usual, I have 3 on this side. Okay, carbon, let's put an 8 there. So we have 8 times 1 carbon. And that matches up with 8 carbons right there, so that puts an 8 there. And now hydrogen, even though it's a big number, it's an easy one. So it's 2. You're going to multiply 2 times 9 to get 18. So this becomes an 18, and you put the 9 right there. So it's 9 times 2 is 18, matches up with that 18. Okay, what does that do to our oxygens, though? I didn't do anything with those yet. So over here I have 8 times 2 is 16, plus 9 times 1 is 9, so 16 plus 9 is 25. So over here our oxygen is going to be 25. Okay, what do you multiply this by so that it equals 25, because it's an odd number? And the answer is, I'll just do it off to the side here, 25 over 2 times 2 equals, the 2's cancel, that equals 25. And that's what you have to get it to be. So this coefficient is going to be 25 over 2. So now everything is in balance. I now have a 25 on this side by multiplying that 25 over 2. So 8, 8, 18, 18, 25, 25. But you can't leave a coefficient as a fraction. So what our coefficients are right now are 1, 25 over 2, 8, and 9. So how do you get rid of that 2? You multiply everything all the way through by 2. So 2 times this is 2. 2 times 25 over 2 is 25. We just showed that right there. 8 times 2 is 16. And 9 times 2 is 18. Scratch those out. Don't need those anymore. And that's the answer. 2, 25, 16, 18. Not very pretty. You don't get a lot of those that do that, but occasionally you will hit one, and you got to know how to deal with that fraction situation like that. Okay, we'll practice some more of those. All right, let's keep going. And what do we got? Okay, I'll use the box method here. Go back to that. Iron chloride, sodium, and it is a hydroxide, so I'm going to treat it like a solo element, okay? You just put a parenthesis around that, so it's going to be OH. Okay, put a parenthesis around that. Then you got Fe and OH, 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 3 of those OHs right there, and then you got Na and Cl. Okay, so sodium matches up 1 to 1. That's good. Fe, this should be Fe actually. Fe and Fe match up 1 to 1. That's good. The Cl, so you got 1, 2, 3 here, and you got 1 over there. So I'm going to need to add 3 more boxes here. Okay, so that gets my Cl's in balance. However, it did throw my Na's out of balance. So I'm going to go ahead and balance the Na's. I need 3 of them now. Okay, so Na's are now in balance, Cl's are in balance, and as it happens, the OH's fall into balance as well. That often happens. The last one you don't even have to balance. It automatically balances. Okay, so this is 1, 3, 1, 3. All right, move on. Okay. This one looks really simple, but it can be a little tricky. I'll use the box method. I might regret it, I'm not sure. Let's see how many boxes I need. Here I have O and O. Here I have a lot of stuff. P, P, O, 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 O. Okay? All right. Yeah, what I said is I might regret that because I'm going to need 5 boxes here because I can see that 5 and 2, I'm going to have 10 oxygens to get it in balance. So that means I'm going to need 5 boxes here. I'll go ahead and do it this way. It's the way I started. I'm going to have to make the boxes kind of small though so they fit. So I got OO. First thing I can do actually is I can add a P here. So now the P's are in balance. Okay, that's done. It's the oxygens that are kind of messy. I'm going to add another box. I'm making them small because I'm going to run out of space. Another one. Okay. Well, actually, if I'm doing it properly, once I get to 6, 1, 2, 3, 4, 5, 6. So let me take this one away. And I only have 5 on this side. Then I have to add a box. You always add a box to the side that has the least. So we're talking about oxygens. So I need to add one there. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 1, 2, 3, 4, 5, 6. So I have to keep adding a couple more boxes. And there we go. We have 10 oxygens on both sides. So this is going to be 2, 5, and that's not right. This is going to be, I've got to balance the P's. The P's are not in balance. So let me start again. I'm not done. Everything's okay so far. I'm just not finished. I have to add 2 more P's to balance with 1, 2, 3, 4 there. So P, P. So I got 4 P's here. I got 5 O's here. And I've got 2 P2O5s there. And that is the correct answer. And there we go. 4, 5, and 2 for that. Okay. So we're going to put sodium in water. And you produce sodium hydroxide and hydrogen gas, which will be flammable. Okay. It actually can cause water to spark when you do that. Let's do that one the other method, the short method. So N, A, N-A, H, and O. All right, I have 1 on this. Okay, so here we go. All right, so I'm going to count. I have sodium here. I have a sodium here. I have H2 here. I have 2 there. I have 1, 2, 3. I have 3 on this side. Oxygen, I have 1 on this side. I have 1 on this side. Everything's in balance except for hydrogen. There. However, everything else is in balance, so you don't have any choice but to try to balance hydrogen first, okay? So, what am I going to do? Well, what I'm going to do is, so this problem is harder than it looks. So how do you do that? You're stuck with having to balance something that appears more than once on this side, and that makes it a little bit tricky. So what I'm going to do is I am going to balance, I'm going to put a 2 here. That gives me 2 hydrogens there and 2 hydrogens there. That's a total of 4. So then I'm going to put a 2 here. So now I have 4 hydrogens. So now hydrogen is in balance. Also, I happen to put oxygen in balance. 2 oxygens there, 2 oxygens there. And the sodium is the only thing out of balance. So I should mark these off as I did them. So the hydrogens, I put that a 2 and made that a 4. I made this a 2 times hydrogen and 2, so I made that a 4, because 2 times 1 and 1 times 2 is 4. The oxygen is 2 on this side, and the oxygen is 2 on this side. Okay, now sodium. So I have 2 NAs and 1 NA. So what I got to do to balance is just put a second Na there. I have 2 over there, and now I have 2 over there. So everything's in balance, there and there. So it's 2, 2, 2, and 1 is your final coefficients. Okay, 2, 2, 2, and 1. All right. Okay, good. All right, continuing with problem 13. Let's just do this the simple way. So you just have silver and oxygen. All right, so you have 2 on this side, you have 1 on this side, you have 1 here and 2 here. Doesn't matter which one you balance first. We'll balance the Ag. So that becomes a 2. That becomes a 2. That balances the Ag. The O still needs to be balanced, so make that a 2. So that's a 2 for the oxygen, and O2 is 2 for the oxygen. So you put a 2 there, but you threw the Ag back out of balance. So it's 2 times 2 is 4 there. So now you have to come back to Ag here and make it 4. Scratch that. That's why you write your coefficients up above until you're done, because you don't know if you're not going to have to do that. Okay, so we end up with 2, 4, and 1. And you can scratch those out on the top, okay? All right. Let's use the box method. No, let's see. No. Because you're going to need 8 boxes to get the sulfurs to balance, so let's not use it there. So we're just going to have S and O. You have 8 on this side, 1 on this side. You have 2 on this side, 3 on this side. Go ahead and put the sulfurs in balance. So you need 8 here of sulfurs to balance with the 8 sulfurs there. But now that means you have 24 oxygens. So let's just make that an 8. And that makes this 24. So 2 times what number would give us 24? Because we need 24 oxygens, and the answer is 12. Okay, so it's SE8, 12O2, and 8 SO3. Okay, so again, sometimes the box method is just impractical because you require too many boxes. That's why you want to get away from it, as soon as you can. All right, so let's see what we got here. Carbon dioxide plus water. This is the plant reaction. Carbon dioxide and water produces a sugar or starch plus oxygen. That's what plants do. All right. Again, I'm a little nervous with all these big numbers about using the box method. So I'm going to do C, H, and O. So I've got 1 C here and 6 here. I have 2 hydrogens here and 12 here. I have 1 oxygen, 1, 2, 3 on this side. And I have 6 plus 2, I have 8 on this side. So that's going to be a little messy. Let's start with the carbon. It's the easiest. Let's start with a hydrogen. So if I multiply this carbon by 6, yeah, it's okay. Let's go ahead and start with carbon. So 6 there, that's going to make this a 6. Okay, so the carbons are in balance. Hydrogens, you have 12 here and 2 here. So let's multiply this by 6. So that makes this a 12. And it makes this a 12. So the hydrogens are in balance. On this side, however, when I did this, I have 6 times 2 is 12 oxygens, and 6 times 1 is 6 oxygens. So 6 plus 12 gives us 18 oxygens on this side. Okay. And what am I going to need to do to get this to balance over here without throwing anything else out of balance? I'm going to go ahead. I have 6 oxygens here. I need to have 18. So 6 plus 12 would give me 18, so I need to make this become 12, so I multiply that by 6. So follow that. So 6 times, there's 6 oxygens here. Now that I put that there, there's 12 oxygens there, so 12 plus 6 is 18, and that's what I wanted. I wanted this to turn into an 18. And over here I already had the 18, that's why I had to do that. That's 6 times 12. Okay, the carbons are balanced, the hydrogens are balanced. And so that's your answer. It's 6, 6, 1, 6. Okay, and that's the answer for that one. Okay, let's come down here. And then this next one, 16. This is a single replacement reaction like you saw in class. You got the K is going to swap places with the Mg, and the Mg is going to become the lone element, okay? We'll talk more about those reactions. So let's just do boxes this time. Okay. Okay. So I've got an Mg on both sides. I have a Br on both sides. I have a K on both sides. Everything's in balance, so it's already done. You don't need to do anything. That occasionally happens. One's in front of everything. All right, let's come on down here. When we did the osmosis, we did something like this. This is calcium carbonate. That's what an eggshell is made out of. We used vinegar, which is a much weaker acid than hydrochloric acid, but you can use that to dissolve an eggshell too. And so what are we going to use for this one? Let's go ahead and let's use the box method. We got space. Okay, it's hard to read. That's a CO2 right there. C and 2 O's. Okay, what are we going to balance first? Stay away from oxygen because there's 2 of them there. Calcium is already in balance. Chlorine would be good. There's 1 there and there's 2 there, so we're going to add a box here. Okay, hydrogens are now in balance, 2 and 2. 2 and 2 there. Oxygens are 1, 2, 3 and 1, 2, 3, so it looks like everything's in balance. So we have 2, 1, 1, 1, 1. Okay, good. Okay, we're going to wrap up this assignment with the last set of problems. So let's get going on this. We can go ahead and I'm going to use the shorter method. So I have NaH. I'm going to treat NO3 as an element. So what you can do is put parentheses around it because you see it appears on both sides. It's not broken up in any way. And I have C. And that's everybody, right? NaHCO. Oh, I have O as well, aside from NO3, so I have O. Okay? All right, so Na, I have 1 on this side, 1 on this side. H, I have 1, 2 on this side, and I have 2 on this side. The NO3s, I have 1 on each side. Carbon, I have 1 and 1. And the oxygens that are not part of the NO3, because we're treating that like it's its own element, I have O3 here. So that's 3. And I have 1, 2, 3 here. Okay, so if I look at this, everything's in balance already. So although this looked like it was going to be really hard, it turned out to not be really hard. Everything coefficient is a 1 because everything's already in balance right there. Okay, to number 19. So I'm going to go ahead and use the box method. I've already started the boxes there. So oxygens. Well, hydrogens. Hydrogens are already in balance. I have 3 oxygens on this side and 2 on this side. So you always add the box to the side that has the least. So I'm going to do this. Now I have 1, 2, 3, 4 oxygens on the right and 1, 2, 3 on the left. And the hydrogens are out of balance, so I'm going to go ahead and add a box over here. So now I have 1, 2, 3, 4, 1, 2, 3, 4 for oxygens, and same thing for hydrogens. So we're done. That's 2, 1, and 2. Okay, let's do this one using the box method. And this is what we call a double replacement reaction. Cation, anion, cation, anion. They switch places over there. Okay? So. All right. Okay, start with anything you want. Sodium's already in balance. Calcium is already in balance. Fluorine is not, so I'm going to add an F over here. That throws the sodium out of balance. So you got 2 Fs, 2 Fs. So I'm going to add a sodium over here. So I have 2 sodiums, 2 sodiums, 2 fluorines, 2 fluorines. Calcium's in balance. Bromine's in balance. So that's good. Everything's done. So it's 2, 1, 2, 1. Okay. And that takes care of that one. And finally, problem. I'm going to do it the shortcut way. So I've got Na. I've got H. Now I have this sulfate here, and it doesn't change over there. So I'm going to just treat that like an individual element. I have a nitrite here. And I have one here, so I'm going to treat that like an individual element. So I'm going to write NO2 here and SO4. I'm not going to break them into their actual element parts, okay? So let's count. We have 2 for hydrogen here, 1 on this side. Sodium, we have 2 on this side, 1 on this side. And the NO2 is 1 on each side, and same with the sulfate, which is 1 on this side and 1 on this side. Okay, so now what do we want to balance? Let's balance hydrogen first, so we put a 2 there. That becomes a 2. That gives me 2 nitrites. So I'm going to put a 2 there because I got to bring the nitrite in balance. And that helps me out with the sodium because now I have 2 Na and I already have 2 Na over there. Everything else looks like it's in balance. SO4, SO4. So it's going to be 1, 2, 2, 1, and that balances everything. Okay, it's just a matter of practice. Don't get frustrated by it, and see you on the next assignment.